Welcome, 7th grade. Today we talk about sample spaces and probability. It still applies that we have our total on the bottom, our desired on the top when setting up these equations. But today we're going to learn to use counting methods to determine possible outcomes. Sample space, fundamental counting principle. Because you can roll the numbers 1, 2, 3, 4, 5, and 6 on a numbered cube, also called a dice, there are 6 possible outcomes. Together, all the possible outcomes of an experiment make the sample space. Total. Desired. That's what I want. 6 total outcomes? If I want a 5, there's 1 of those out of the 6. Oh, sample space is your total that you generally put on the bottom. We've got our dice that we're rolling. You can make an organizational list to show all the possible outcomes of an experiment. All right? You can make a list. Now we're going to jump right into this. One bag has a red tile, a blue tile, and a green tile. A second bag has a red tile and a blue tile. Vince draws one tile from each bag. What are all the possible outcomes? How many outcomes are in the sample space? Now, we're going to draw what's possible here. We have to understand the problem first. Find all the possible outcomes. List the important information. There are 2 bags. One bag has 3 tiles. The other bag has 2 tiles. The first one has red, blue, and green. The second one has just red and blue. So let's make a plan. Plan and get organized. Okay? R for red, B for blue, G for green. Record each possible outcome. Okay? From bag 1, I could draw a red, and then from bag 2, draw a red. For bag 1, I could draw a red, and then a blue. That's all the possibilities with red. Then I could do blue-red and blue-blue. And then I could do green-red and green-blue. 1, 2, 3, 4, 5, 6 different possibilities. Oh, we made that chart. And we found that there are 6 different possibilities. Our sample space is 6 different possibilities. We look back. Each possible outcome that is recorded in the list is different. Now, many of you may have saw that 3 times 2 was 6. We're going to get there. Darren has 2 bags of marbles. One has a green marble and a red marble. The second bag has a blue and a red marble. Darren draws 1 marble from each bag. What are the possible outcomes? What are all of them? One has a green marble and a red marble. The other has a blue and a red. Let's see. We got to understand the problem. All right, get the important information. 2 bags. First one, green and red. Second one, blue and red. Make that plan. All right. First bag, I could draw green then blue, green then red. Red then blue, red then red. Oh. 1, 2, 3, 4 different possible outcomes. 2 in each bag. 2 times 2 is 4. All right, we look back. Each possible outcome is recorded. The list is different. Very good. Now we get a little bit harder. There are 4 cards and 2 tiles in a board game. The cards are labeled N, S, E, and W. The tiles are numbered 1 and 2. A player can randomly select 1 card and 1 tile. What are the possible outcomes? I bet there's 8. Why? 4 choices in the first one, 2 in the second one. Wonder if I'm right. All right, let's make a tree diagram to show this. So we're going to do a little bit different than the charts we've been doing. All right? Now, if I draw the north, I could draw a 1. If I draw a north, I could draw a 2. Oh, 1 choice, 2 choices. For the south, I could draw a 1 or a 2. For the east, I could draw a 1 or a 2. And for the west, I could draw a 1 or a 2. 1, 2, 3, 4, 5, 6, 7, 8. 4 choices. And then 2 choices in the second one. 4 times 2 is our 8 that we have. Do you see how for the north we could have 1 or 2? South 1 or 2. East 1 or 2. West 1 or 2. All right? There are 8 possible outcomes in the sample space. There are 2 marbles and 3 cubes in a board game. The marbles are pink and green. The cubes are numbered 1, 2, and 3. A player can randomly select 1 marble and 1 cube. What are all the possible outcomes? 2 in the first choice, 3 in the second choice. There's going to be 6. Let's see. We're going to make our tree diagram. All right. If I get a 1, I can have a pink and a green. If I get a 2, I could have a pink or a green. If I get a 3, I could have a pink or a green. 1, 2, 3, 4, 5, 6 different outcomes. All right. Now, in additional example 1, there are 3 outcomes for the first bag and 2 outcomes for the second bag. In additional example 2, there are 4 outcomes for the cards and 2 outcomes for the tiles. If we look at these, 3 times 2 is 6. 4 times 2 is 8. The fundamental counting principle states that you can find the total number of outcomes for 2 or more experiments by multiplying the number of outcomes for each separate space. There were 3 possible outcomes for the first bag, 2 possible outcomes for the second bag. The sample space was 3 here, it was 2 here. 3 times 2 is 6. That's the total outcomes. Sample space was 4 here, sample space was 2 here. 4 times 2, 8. That's the total outcomes. Carry rolls 2 1 through 6 numbered cubes, 2 dice. How many outcomes are possible? A dice. A dice. How many different things can happen if I roll this dice? How many different outcomes can I have? I can get a 1, a 2, a 3, a 4, a 5, or a 6. There's 6 different outcomes. How many outcomes can I get when I roll a 1, a 2, a 3, a 4, a 5, or a 6 over here? There's 6. How many total outcomes are there? 36 different outcomes. With those 36 different outcomes, there's 36 different possibilities that you could come up with. Let's see how they approach it. Okay. List the number of outcomes for each separate experiment. The first numbered cube has 6. The second has 6. So we use that counting principle. There's 36 outcomes. There are 36 possible outcomes when Carrie rolls the numbered dice 1 through 6. Now, Sammy picks 3, 1 through 5 numbered cubes from a bag. After she picks a numbered cube, she puts it back in the bag. How many possible outcomes are there? Picks 3. So you have to think. Choice 1, choice 2, choice 3. I draw on that bag. There's 5 different numbers in there. I have 5 different chances here. Okay, I got that. I put it back in there. So when I draw the second time, there's still 5. Oh, good. I look at my number. I put it back in there. I draw the third time. There's still 5 choices in each bag. When you multiply all those, 5 times 5 times 5 is 125. There will be 125 different possible outcomes because we put that back. Oh, sorry. $125 because there's 5 chances each time you pick. Okay? We can start and we can go. Thank you guys. We're taking baby steps. We'll get there.